For this problem, we're asked to factor and find all the zeros and then sketch the graph. So if we look at this two-termed polynomial, it's either a difference of squares or a sum or difference of cubes. In this case, it looks like it is a sum of cubes. So it looks like our a is going to be x, because x cubed would be x cubed, and b is going to be 3, because 3 cubed would be 27. So then we can write our factored form as x plus 3, x squared minus 3x plus 9. So I used that SOAP, same sign as the original, opposite sign as the original, and always positive sign right there. And then to get the values inside, it was a times itself, a times b, and b times itself. Now this is actually the fully factored form of this expression, this equation, because this is linear, and the quadratic produced by doing sum or difference of cubes is never going to be factorable. So here I don't even have to try factoring that quadratic because it's never going to be factorable from a cube. So then for our zeros, our solutions, we have 1, x equals -3. And then for the quadratic, we're going to do the quadratic formula to figure out those zeros. So x equals -b plus or minus square root of b squared minus 4ac all over 2a. That's going to be 3 plus or minus, that's what, 9 minus 36 is -25 all over 2. Which is 27, sorry, 27. So x would be, that's 3 plus or minus, 27 is 9 times 3, which would reduce to 3i root 3 over 2. So those are the three solutions. This is the only root, because it's the only real solution, but these are two other solutions that we also get. Now, we're not going to see these on the graph, though, because they are imaginary. So to graph this, there's actually not a whole lot to it. We know one x-intercept is -3. We know the y-intercept is the constant, 0, 27. And then we know that the end behavior is going to be like a positively sloped line, so from down to up. So the graph looks something like this. Since it's cubic, I added the curve in there because it's obviously not a linear equation, so it's not going to be just like a line. But this is this is what we know right now about this graph. So that's a good sketch of the graph.